Welcome back to the Monday morning Haskell video blog, where we're still constructing different parts of our Haskellings program, an automated tutorial for teaching beginners about the ins and outs of Haskell. And this week, our focus is going to shift to unit testing. Last time out, we refactored and reconfigured our program so that it could use the handle abstraction so that its inputs and outputs can come from files, in addition to being, a command line application, in addition to putting all its output to the terminal. And we'll see this week how this will help us write some unit tests. One note I do want to make about the config before we get started: I didn't have this change in last week, but it'll be important for our testing purposes that the exercise extension, so essentially the directory relative to the project root where our exercises live, this is another element that we want to be configurable in our program, that our tests are going to want a different set of exercises from the main program. So that's one little change I want to make note of. But yeah, as far as writing a unit test, we start off, of course, with a test suite in our Cabal file. So I've just called this Haskellings tests for right now. It'll go in this main directory. And in addition to using our Haskellings library as one of its sources, we're also going to go ahead and use the hspec library for these unit tests. We'll see a little bit about how hspec works. And let's just take a quick look at our test directory, just the structure of this. So as I said, we have our own exercises here. We've got our own test versions of these exercises. So we have types, bad as sort of the original. So this is incomplete, where it won't compile. And then we also have the good version, where this should compile. And so for our unit test, we're just going to essentially assert that our program can attempt to compile these two files and that it will give appropriate output in both cases. We also just have this test gen directory here. This is actually get ignored. This will just be a place where we can put our output. So with all that out of the way, let's jump into our main test runner. I have just a very a test is basically an executable, so it just has this main IO function right here. And we're going to start off just by loading our project root in GHC. This is an important part of configuration, so we'll be in our test suite by doing that, just like we do for our normal program. So this gives us the project root and the GHC path, which is pretty important for us. Now, hspec is intended to be this way of writing our tests in a behavior-driven development way, where we're describing the higher level intent of the test with the various statements and the syntax that we use for it. But one of the really cool features about hspec is its system of before and after hooks. And in this week and then next week, we'll see two different ways that we can use these hooks. And these essentially allow us to run particular IO actions that may require, claiming resources, system level resources, that is, before running our tests. And looking at our program as something that compiles files, and we'll be taking input from files and sending output to files. This is actually a pretty important concept. But the paradigm we'll explore this week is that we just do all of the work, all of the essential work of our test program in the before hook, and then after that is done, we'll just take the outputs of that and evaluate them. Next week, when we write unit tests for the watcher, we'll do something a little more complicated. But let's actually start by writing a before hook. So a before hook always has the general, it's essentially just an IO action that returns something for us. So in our case, the final output we want from our program is going to be a string, which will be the all of the output that goes to standard out in the main program, but will actually be output to a file in this sort of tested version of our program. And we're also going to want the exit code that our program returned. So I'm just going to say this is essentially a compile before. But of course, we'll need some parameters for this before we call it, but we'll get into the details of this function in a moment. So the way we use before is we say, the before function, and then we're going to go ahead and essentially put our before hook here. So compile before hook. And then we can go ahead and write our test assertions. Of course, this will need to be fleshed out. It will need to have some more parameters to it eventually, but we can just write our assertions now, imagining that we have the results of this before hook, so that we have the string and that we have the exit code. So here's how we start any spec test. We use describe, and we can say, when running, let's say compile exercise with a non-compiling file. So we'll start with a failure case. Actually, we don't need this do, and we use it. So it is essentially the assertion, the function that triggers the assertion, and it starts out, it is called it because this allows us to write a sentence basically for what this expression should say. So we say it should indicate failure to compile and return a failing exit code. Now, because the inside of this, so everything that's going on here, I misspelled when. I misspelled it again, isn't that funny? So the inside of this is actually, it's a type called spec width, and the spec width is just the output type of our before hook. So spec width, string, and exit code. And what this means is that when we make these it assertion declarations, we can imagine that those take the spec width type as an input. So we have our exit, and now we can start running assertions. These are fundamentally just IO actions, but we can also write within the hspec library. They're referred to as expectations. And the first one we'll note is that exit should not be. This is one of the different combinations we can use within hspec. There's should be, should not be. Should not be exit success because we're passing a failing test. And again, we can notice how this assertion line, it reads a little bit like a sentence, and that's so that maybe a non-technical user can read this test file and understand essentially what's going on. Now we can also do something similar with our other case, with our success case. So with a compiling file, it should indicate successful compilation and return a success error exit code. And in this case, exit should be exit success. Now, we went through all that trouble last week of really getting our output to go to files instead of going to the terminal. So we'd also like to run an actual assertion on that output. So that's why we have this string. This is where we will put that ultimately. But let's write a couple of expectations that will look at that string and analyze and say, okay, is this what we want? So the first one we're going to write is failure output. This takes a string and it gives us this expectation. Again, this is really just an IO action. That's what an expectation is, but it helps to use types that describe what's happening. Now, the way we're going to know if something is the failure output, we're going to divide it into its different lines. And one thing we should note is that there should be multiple lines. Anytime our program fails to compile, there should be at least 2 lines, because our program is going to print the first line that says, we couldn't compile this. And then the second the rest of it is just going to be the actual compilation error. So we can say length of output lines should satisfy, this is another common error we can use, passive Boolean expression, should satisfy greater than 1. And then the other length of output, hold on, this thing is not right here, output lines. And then the head of output lines, this should satisfy this prefix of, and so this is saying, you know, this line should start with good compile. And the rest of that line is going to be the actual name of the module, but we won't care about that for right now in our tests. So we can then go ahead and add this as an extra condition on this unit test. So we'll say it's failure output, and we'll just use our output variable that we got from our before hook. That's the end of this assertion. The next one, we have the success output. And really, this should only be one line, and similar to how we have, you know, the prefix should say couldn't compile on this one. This should satisfy this prefix of successfully compiled. So that's our successful output, and we'll also add that as an extra condition here. So that's the general shape of our tests. And now we really have to deal with the much more tricky question, which is how do we actually populate this before hook? How do we get this information? How do we compile the exercise? Because up to now we haven't actually told it anything about what files we want it to be running. So to really make a determination there, we have to actually give some inputs to our before hook. And to really do that properly, we have to think about, okay, so what exactly, what exactly is going to be happening in this? And, you know, at some point we want to be calling our compile exercise function from our utils module, like that. At some point we want to be calling compile exercise. And we should keep in mind, for our own sake, what is the type of that function. This is ultimately what is under test. So we're going to need a config. Say conf is undefined right now. And we're going to need some exercise info. And we'll pass these in to compile exercise, configure, you know, the program configuration. And we'll pass the exercise info. Actually gonna give that a longer name so that's not confused with exit info, because that is the exit code rather is what we're getting from this function. So we're saying result exit, and this result exit is going to be the first thing, or really the second thing, given how we've written the type function of our before hook. We're returning the exit code, and we're also returning the output of running this compilation. So now we have to ask ourselves, okay, how are we going to get that output? We need to populate this configuration, and we also need to really understand, okay, you know, what needs to be configured about this test. And so these are actually going to be parameters for our before hook. So we'll start with you know, the basic paths, the project root and GHC path. These will be important for us. And then we're also going to take our input file, so the file that we are trying to compile, and then we're also going to take an output file. This is where we are redirecting that output instead of putting it to the command line. So with these variables, actually we're going to say root. File. So now we can start making our configuration. Well, actually not quite yet, because first we need a handle to represent this output, you know, file. So we have to create the full file path for that output, and in this case we'll say full fp, and this is the project root we're going to add our extension for the test directory. Let's say test/testgen, and then add this out file. So this is where our output's going to go. So we now want to open up this file. This we will pass into our configuration. As a note, we will need to close this handle at the end. Since it's a write handle, it's not going to be saved essentially until we close it. But now we have enough information to make our configuration. So this is a program config, the project root, the GHC path, and then one exercise directory. So instead of source/exercises, this is going to be tests/exercises. And then we'll just use the send in handler. We'll use this out handle we got from our file, and then we'll also pass standard error handle. Now, we're just about ready to run compile exercise, and for our exercise info, we'll actually hardcode most of this. We'll just say, it's test, and for now, all of our tests are going to be in the types directory. We'll probably refactor this to be another input eventually, but say infile is effectively this is the Haskell module that goes as the last piece of that exercise info. So now this is complete. We still don't have our output string though. And indeed, to get our program output, we need to take that file that we just wrote to, and we need to read from it. So read a file handles, opening and closing the handle again. So we don't need to worry any more about that. And then we'll just return program output. And that should be the final piece of the puzzle for us. We should now be able to go ahead and run these tests. Just going to open another window here. So let's go ahead and run stack test. Okay, so yeah, so notice how we added extra parameters to our before hook. So of course we're going to have to add them here. Can't just have the compile before hook sit there on its own anymore. So we'll say paths, and this is where we actually specify our input. So we'll specify our input file. We'll say types bad, and we'll just give an arbitrary output file. So we'll say types1 bad.output. This will just get put in our test generated directory. We don't have to care too much about that. And we'll do the same thing out here, except with good. And now let's give it a try. And there you have it. Our test is run. It's looking at these output files and running our tests. Yeah, that's all for this week. It'll obviously be a little more tricky to test the watcher functionality, so that's what the challenge that we're going to try to handle next week.